I came across the term synaptic pruning, and this is how they explained it to me. Basically, it's a neurological process that happens mostly in youth, especially between the ages of 2 and 10 years old. For the first 2 years of an infant's life, the brain rapidly forms connections between neurons. The synapse lies at the end of each wire, called an axon. Synaptic pruning is the process of eliminating some of those connections. The goal of synaptic pruning is network efficiency. Useful connections are prioritized over ones that are used less.
Synaptic pruning is the process of synapse removal that takes place naturally as part of brain maturation. A human brain starts its development in early embryonic stage and reaches the maximum number of synaptic connections sometime in early childhood, at which point it is about double of what is normally present in an adult brain. This is when the elimination of excess neuronal synapses, known as synaptic pruning, begins. The process removes roughly half of all synapses and occurs mainly during adolescence, but may continue well into young adulthood. By getting rid of unnecessary connections, synaptic pruning helps to refine neural circuits and increase network efficiency. Computational models suggest that learning performance is optimal when synaptic connections are first overgenerated and then pruned. An analogy is the task of writing an essay. The easiest way is to put all possible ideas into a longer than needed first draft, then trim it to keep only the essential points to create an effective final message.
But in autistic individuals, the process of pruning unnecessary connections is slowed down. Autistic individuals simply maintain a lot of those connections, which then explains why we are so sensitive. Before I ever learned about what trauma is, and then later what autism is, I came across the highly sensitive personality trait and introversion, and that was way back in 2012. And I read all the books, of course. Again, that's just how I am. And this author, Susan Marletta Hart, her book about HSPs is really great. And just the other day, I looked at it again and I compared it to Asperger's, and it's just so similar. It's so similar. See for yourself. So here is the website of Susan Marletta Hart. She is a Dutch author, and her book is only available in German, not in English, but at least her website is in English. So she writes, high sensitivity is a trait that can be explained both positively and negatively depending on what you focus on. Who is highly sensitive? Notes many details and subtleties, senses moods of others, has a rich inner perception world, dreams, fantasizes, philosophizes, and considers a lot, is often caring and aware, likes to do things at their own pace, is deeply moved by beauty and art, likes silence and peace. So that's actually a description of me. And then she goes into the symptoms and compare it to Asperger's. It's basically the same. As an HSP or autistic, you are more likely to suffer from disturbances from your environment that others do not seem to notice. Loud noises extract you from yourself or literally hurt. You feel someone's mood. You get upset by people with pronounced negative feelings. A few hours of shopping will bring you to the limit of your ability. You want to go home, retreat into loneliness and solitude. Loneliness is a bad word. And have nothing on your mind anymore. Yeah, hunger makes you feel lightheaded quickly, yes. Working in a hectic office environment costs you much more energy than your colleagues. Unfriendly comments, criticism can quickly upset you. On the other hand, you feel deeply moved by warm tension. You soon suffer from stress symptoms such as stomach pain, restless intestines, headache, itchy nerves, or different feeling of unease. Feelings of anger, which is fight response, sadness, freeze response, despair, anxiety, of course, quickly take a walk with you. Everyone is different and everyone is raised differently. This creates a lot of behavior in the course of your life that you developed in order to deal with this high sensitivity as best as possible. We call this behavior coping. Strong control, same as in autism. Perfectionism, dream away and fantasize. I did that as a kid a lot. When I was stressed out and there was no way out, then you withdraw. Withdraw from social life, withdraw within. Humor, be busy, this is the flight response. Anger attacks, again, fight response, and that's the classic meltdown in autism. Time and space. In the first place, a highly sensitive person needs more time and space than the average person. This is purely because the amount of stimuli that come to him or her must be sufficiently processed. This is sensory information that someone receives through their eyes, ears, nose, and touch. And emotionally too. But also for information that comes from within, from your thoughts, your feelings, your organs. In short, all physical, mental, emotional, and spiritual sensations. Additional time in silence is required for processing. It is very obvious to me that in this society that is so obsessed with behavior and everything else that doesn't fit in is pathologized, well, of course, people who do not fit in will develop complex PTSD symptoms. And for highly sensitive people or autistics, many things are stressful and traumatic, which are not in the DSM-5. Which you see here on this graph. For me, that was certainly the case. School was another trauma. Social difficulties. Not feeling accepted and welcome. Bullying, yes. And then comes also the childhood trauma, violence against the parent by the other. That was one of the biggest traumas at age 13. Being sent to summer camp at age 12, also traumatic. And then apprenticeship was traumatic. Relationship was traumatic. Work situation was traumatic. Yeah, so there are many, many traumas through my whole life. A review of thanatosis, which is death feigning as an anti-predator behavior. Abstract. Thanatosis, also known as death feigning and, we argue more appropriately, tonic immobility, is an underreported but fascinating anti-predator strategy adopted by diverse prey late on in the predation sequence and frequently following physical contact by the predator. TI is thought to inhibit further attack by predators and reduce the perceived need of the predator to subdue prey further. Predation is fundamental to the lives of wild animals, influencing key aspects of fitness such as feeding, breeding, and often, ultimately, mortality. In response to the threat of predation and the fitness caused to an individual associated with such predation, natural selection has resulted in the evolution of a wide variety of morphological, physiological, chemical, and behavioral defensive adaptations in prey species. Very few animals are immune to substantial threat of predation in at least one stage of their ontogeny. As such, the many and sometimes complicated adaptations involved in predator-prey interactions are of great interest to behavioral ecologists. An interaction between a predator and prey individual can often usefully be broken down into a sequence of stages, beginning with the two individuals being in proximity and leading through detection, identification, reducing separation, contacting, subduing, and finally consuming. There is a diversity of mechanisms that prey have evolved to avoid attack by predators, some of which require deployment at particular stages in the attack sequence in order to be effective. One interesting and well-known defense that prey can exhibit late in the sequence of a predation event is tonic immobility. TI has been discussed in scientific literature for over a century. Tonic immobility can be viewed as a last resort, occurring not only after the prey has already been detected by the predator, but most often following physical contact between the predator and its prey. This makes it quite distinct from immobility used to reduce the risk of predator detection or tracking. Since such freezing occurs much earlier in the sequence of a predatory attack, that is, we consider stillness that enhances the effectiveness of camouflage or masquerade to be a different process from TI. Further, some animals, e.g. pillbox armadillos, adopt a curled posture that makes vulnerable body parts inaccessible to predators. We consider this too a separate process of TI, which does not rely on making the prey physically less vulnerable to the predator. TI typically occurs when animals are physically restrained, and it involves prey adopting a relatively immobile state that can last from seconds to hours, even after the physical constraint has been released. In some vertebrates, the behavior can involve reduced breathing rates, bradycardia, tongue protrusion, and setting the eyes wide open. Features very reminiscent of dead individuals of that species. TI is, therefore, also known as death feigning, playing dead, playing possum, animal hypnosis, and thanatosis. By offering the following definition of TI, we hope to clarify the scope of our current study. Tonic immobility is the unlearned adoption of a motionless posture by a prey individual triggered by physical contact or very close proximity of, not injury inflicted by, a predator or other antagonist. The posture does not reduce the sensory ability of the predator to locate or identify the prey, or reduce the physical vulnerability of the prey if the attack is pursued. The state of motor inhibition is maintained for a time, even after release by the predator, and when in this state the prey exhibits reduced responsiveness to external stimulation, although monitoring of the environment can still occur. In the absence of mortality or injury during TI, the prey can recover its original physiological state on emerging from TI. The GABA and opioid peptides are critical neurotransmitters that modulate the activity of the neural substrates that command defensive behavior, especially those located in the midbrain. Considering the rostral aspects of the dorsal midbrain, there is evidence that pre-treatment with opioid antagonists decreases fear-related responses elicited by the electrical stimulation of the periaqueductal gray matter, PAG, and deep layers of the superior colliculus. The proposed action of these opioid antagonists is based on the inhibitory interaction between endogenous opioid peptide containing neurons and GABAergic pathways. Our conjecture is that people with Parkinson's disease, as well as catatonia, are stuck, but by addressing the triggers in their environment, can markedly reduce symptoms. They can also temporarily escape via exogenous dopamine supplementation, but this has severe long-term consequences. Catatonia is a more episodic manifestation where the person can come back to life without external help, but I speculate may become more and more prone into being triggered into the state the more the nervous system experiences. Playing possum is known more scientifically as death feigning or thanatosis, as we have seen before, but it's not acting. It's not voluntary at all. It's a built-in physiological defense system that is automatically triggered as a last resort response to an otherwise inescapable death. The body's nervous system sets off a cascade of neurochemicals and hormones that dramatically affect the function of the many parts of the brain, as well as organs throughout the body. It's distinct from orienting or startle freezing when a predator approaches. Organisms do that to keep quiet and hide, but they are ready and able to move fast if they are detected. In thanatosis, the body cannot move, so many scientists refer to the phenomenon as tonic immobility. Tonic, in this context, relating to muscle tone and referring to a prolonged contraction of muscles. My personal experience, and I believe Lillian's through hand-on via Rosen technique, is that the stiffness is not in the muscles per se. I believe it is in the facial and connective tissue. The fact that so many different species experience tonic immobility shows that it can be an effective defense mechanism. Only recently scientists have recognized that humans also experience it. Mainstream science is starting to catch up with this reasoning. We also think there must be an element of smell which triggers the predator's disgust circuits that prevent it from eating rotten food. The video of the interaction of a dog with the opossum playing that we shared before is also telling in this regard. Interestingly, people with PD have a peculiar smell that dogs and even some people can pick up, and could be used as a diagnosis point.
Endocrine, even stress and bullying are recognized as triggers for catatonia. And I use the word triggers very generically. And it's not too surprising that the last group to be recognized to develop catatonia are the kids with neurodevelopmental disorders. In 1970, Rudder actually published that 12% of adolescents with autism had a regression in their language. They developed inertia and intellectual decline. Which, looking back over his work, he was probably discussing catatonia. Doshi in 1998 described catatonia and said that it responded to neuroleptics and benzodiazepines. There are a number of other papers, but I'm going to tell you a little bit about the work that comes from England, Lorna Wing was really the leading researcher on catatonia in London. She had a daughter with catatonia and autism. And she described in her group of about 500 patients, 17% of them developed catatonia-like deterioration between the ages of 17 and 50. And it was a marked deterioration, but generally gradual. Stupor was rare, and symptoms seemed to wax and wane. They suggested that there was a precipitating stress, and they suggested stress reduction therapy. That's pretty much where they still are today in the British Isles. Overall, though, it's now considered that 12 to 20% of individuals develop catatonia, and we can't really say exactly what it is with one person with autism and one person with a neurodevelopmental disorder that sets them up for developing catatonia. This 12 to 20% comes from 4 international studies. The group that I've worked with the most are individuals with Down syndrome, and papers by Dr. Gaziudin from University of Michigan really sort of set the stage for that from her work on catatonia and all types of disorders, including autism. Some pictures of a young man with autism, because he really is a good example of what we see, though I'm going to say probably not the most severe. He was diagnosed with autism when they lived in Indiana when he was 3. He underwent a pretty classical autistic regression at 18 months. But despite that, his parents described him as a happy kid, interactive. He loved cars. And when I saw him in September of 2014, he was really quite catatonic. He had a respiratory infection in the spring of 2013 and then regressed. He stopped going to school. They took him out of school. He stopped going to the store. He didn't use his iPad anymore. He wouldn't go on the trampoline or swim. He had motor slowing, freezing in his motor activities, aggression, and skin picking. He'd pull out his pubic hair. He had weight loss, neck tics, sleep constipation, the whole bit. And he had a diagnosis of depression. Well, Lisa Bailey, who is a case manager at Boone County Family Services, saw him in September of 2014 and said, Siobhan looks like he's got catatonia. And I make that point because we're not going to see all of these kids, particularly the kids with autism. He was in a school situation where the teacher that just thought he was obnoxious and really was, I would have to say, was almost cruel to him. So if the other people we work with in our communities who are seeing these kids, they're going to be the ones that are picking up catatonia, particularly the speech therapists as well. And the difficulty with autism, sorry about that, but the difficulty with autism and catatonia is there is an overlap in symptoms. But if you know autism and you know catatonia, you can generally sort out the differences in the symptoms. And what we always talk about is, our brain does a number of wonderful things, but it only does so many. And so speech, for instance, can be affected by many, many different disorders. Rigidity can be due to many, many disorders. But, We say the eyes only do one sort of thing and the ears only do one sort of thing and the brain does things. So you can't just look at lists of things and say, this is in one disorder and this is in another. This Bush-Francis scale, I have a computer link that you can get this off our Thompson Center website. But this is the most widely used measure both clinically and in research. It has high inter rater reliability, sensitivity, and specificity. It's been validated in many mixed psychiatric and medical cause groups of catatonia. And you go through these 14 symptoms, and if you get 2 or more that are positive, you think seriously about catatonia. If you get to 4, it's just about a slam dunk. So this is, again, the immobility, the mutism, sitting and staring without scanning the environment, sometimes with decreased blinking. Posturing, these are the kids that sit with their heads down when I first see them, or will just stand there, sort of what we think of catatonia in the old days as the person who just stands and doesn't move for hours, but sitting and standing for long periods. Facial expressions, stereotypic movements, repeating different words or phrases, and it's different than generally the echolalia we see so commonly in kids with autism. Negativism, which is really very interesting because the parents really pick up on this. These are kids who used to be easy to get along with. I remember one dad saying, I asked him if he would bring his dish over to the kitchen, and he said no. So there's this contrariness that develops that's very different. This withdrawal, refusing to eat or drink or make eye contact. And then you can also have episodes of extreme hyperactivity, motor unrest, which is non-purposeful. There are another 9 symptoms that we don't count to look at the diagnosis, but they do get counted as we figure out how severe the disorder is. The ones that are most likely to occur are impulsivity and kids that will just all of a sudden take off running, take all their clothes off without any provocation. And the getting stuck is a sort of a bellwether symptom with catatonia. Actually, the first I learned about catatonia was at an ATN meeting in California. And I can still see the pictures of the young man going up the stairs and just stopping in mid-step and freezing. Autonomic abnormalities, which is sort of what leads into malignant catatonia, which we won't go into very much. Flushing seems to be common, inappropriate sweating, all these autonomic nervous system problems. Now I've got some videos. Andy's father is a wonderful videographer, so he sends me all of these. So Andy's just trying to close the door, something he could do effortlessly before. And here he is sitting at his desk where he liked to eat. And you note him trying to eat, how slow it is. And it's not surprising that parents will say it takes kids 2 hours to eat a meal. Gave him this drink, I can't remember what it was, and he took it and he slugged down the whole thing and then promptly vomited. So I don't use that as a test anymore. And here you see the facial grimaces and the shoulders shrugging and the body tics.
I can highly recommend this book, Janina Fisher, Healing the Fragmented Selves of Trauma Survivors. It uses the eternal family system model, which is very, very helpful. when you combine it with a nervous system-based somatic approach. So here, it clearly says, for some, eye contact may have been a lifeline, leaving the client with little ability to disengage from staring at others. But for some individuals, eye contact might have been an aversive experience of looking into frightening eyes. It was with me and my dad when he got angry. Holy shit. I hated his fiery gaze or whatever you want to call it. So, yeah, it's not comfortable looking into such eyes, resulting in habits of disengaging or looking away later, noted by therapists as so-called poor eye contact. It's always what they point out in autism, poor eye contact. Why? Nobody's asking why. What is the cause of that? Maybe it's trauma. Without awareness that habits of eye contact tell us valuable information about early attachment experiences. Where clients sit closer or farther from the therapist, whether their bodies are oriented toward or away, lean toward or pull back from the therapist, already provide us with important information about the client's attachment style and history. There you have it.
And there's Javon with his head down and his hand up in front of his face, which is and kicking a kid in a wheelchair. This position with the head down and not looking at people is a very common posture that I see when pre-treatment, walking up this. And he just is very uncomfortable with this. Just it's all available. The catatonia of the pathophysiology is pretty well worked out. It seems to be an imbalance between the GABA and glutamate neurotransmitter systems. GABA is an inhibitory neurotransmitter, glutamate's excitatory, and we end up with too little GABA and too much glutamate, and the goal is to increase GABA.
An excitotoxin is exactly what its name says. Most people know what a toxin is. A toxin is a poison. Exciting is something that excites you, causes excitation. And an excitotoxin basically is any substance that causes brain cells to become very excited. And they start firing their impulses very rapidly. And they fire so rapidly that this cell will become exhausted and die. This occurs over about an hour's period. So if you take some brain cells and you put them in a petri dish and you expose them to these excitotoxic substances, the cells start firing real rapidly, but they look normal during that 1 hour period. You look at them, they look perfectly healthy. And then at 1 hour, they just suddenly die. And this is going on in your brain if you take these excitotoxins into your body. It does the same things. There's particular cells inside of your brain that will become very excited. And they'll become excited to the point that they'll die. Because at the present time, excitotoxins, the subject of excitotoxins, is the hottest idea and item going in the field of neuroscience. That is the study of the brain and the nervous system. Every journal that has anything to do with the brain and the nervous system is filled with articles about excitotoxins. Every research laboratory that is dealing with the diseases like Alzheimer's disease, Parkinson's disease, Lou Gehrig's disease, Huntington's disease, all these terrible diseases of the brain, the number one thing that they're talking about is excitotoxin. But with all this flurry of activity and the fact that they have named this the decade of the brain, that we're going to concentrate all this money and all this effort in studying how the brain works and solving the problem of these terrible diseases of the brain. Despite all of that, hardly anyone in the general public has ever heard the word excitotoxin. And that's not by accident. It's because the number one source of excitotoxins in our society is in your food. And it's not in your natural foods, it's being added to your food by the industry that processes foods. And they're adding it in very large concentrations. Humans are more sensitive to the toxicity of MSG than any experimental animal. We're 5 times more sensitive than the next most sensitive life form, the mouse. 5 times more sensitive. We're 20 times more sensitive than a rhesus monkey. Well, we know that in the human brain, even in an adult, there are certain areas of the brain in which there's no blood-brain barrier. For instance, if we look at the pituitary gland, the posterior pituitary gland, there's certain critical areas of the brain that have no barrier. So anything that's in your blood is going to go into your brain in those areas. These are very critical zones of the brain. So that shows that that part's a lie. And we know that even if you have a normal intact part of your brain with a normal blood-brain barrier, if you have a high level of glutamate in your blood, over time, it'll penetrate even the normal blood-brain barrier. And third, we know that there are frequent causes in which the blood-brain barrier is disrupted. These aren't rare conditions. Strokes, that's not rare. Think how many tens of millions of people in the United States are walking around who have had a stroke. Many don't even know they've had a stroke. We call them mini strokes. They occur in silent areas of the brain. It opens up the blood-brain barrier. Whatever's in your food is going to go through there. Head injury. Millions of people have had head injuries. Hypertension. How many people in this country has high blood pressure? It'll open the blood-brain barrier. Diabetes, a common condition. If you've ever had brain surgery, if you've ever had a heat stroke, when you have a high fever, it opens your blood-brain barrier. Certain drugs that people take for different conditions will open the blood-brain barrier. Multiple sclerosis is a common disease in which the blood-brain barrier is open. That's what happens. Every time they have this onset of symptoms, the blood-brain barrier is opening up, and that's why they have the symptoms. So if they're consuming food with a lot of MSG in it, or NutraSweet, or other excitotoxins, it goes through these openings in the MS plaques in the brain, and they get a lot worse. And what we find in the MS patients is if they consume a food with MSG, they will get worse for days or weeks afterwards. It's a prolonged worsening. Every time they consume it, they get worse again. They go to their doctor says, oh, that's just the natural course of the disease. It's not the natural course of the disease in these instances. They're poisoning themselves. Severe hypoglycemia. If you have low blood sugar, it'll open up your blood-brain barrier. So if you're a diabetic, and hypoglycemia is common in diabetics who are using the insulin, their blood sugar will fall real low. That opens the blood-brain barrier. If they're doing what most doctors in this country tell them to do and use NutraSweet, when they open their blood-brain barrier during one of these spells, it's being flooded by toxins. If you've had a radiation, in other words, if you get X-ray treatments to your head, it opens up your blood-brain barrier. And if you have infections in that area, it'll open up the blood-brain barrier. There was an experiment done by a person who does a lot of defending of MSG, saying it's safe. And he did an experiment on animals in which he fed them carbohydrates, and his conclusion in the paper was the carbohydrates blocked the toxicity. Well, I got his paper and I read it, and that's not what the paper said at all. What the paper found was that if you take high concentrations of sugar or refined carbohydrates, you will reduce the toxicity, but it still causes brain damage. Now, I was interested just how much carbohydrate or sugar does it take to give any protection? Well, according to his paper, it would take about 10 to 15 packs of sugar, these little packets of sugar. You'd have to eat that every time you ate a meal to get any protection. And in his own paper, anything less than that offered no protection. Or you'd have to eat 17 soda crackers every time you ate a meal that had MSG in it to get any protection. So that argument kind of fell to the wayside. So we see that three big lies have just gone by the wayside, but they never give up. They come up with another one. Now, these are the disguised names of MSG. Once they found out we were hot on the trail, they said, well, our only alternative is to change the names so the public doesn't recognize it. And this is just a partial list of the names that they have come up with. Frequent one is hydrolyzed vegetable protein. You see that in many, many foods, a lot of soups. You'll see it sold at health food stores. When you hydrolyze a protein, what you do is you break it down, you release its amino acids. One of the higher concentrated amino acids is glutamate. Another one is aspartate, which is also an excitotoxin. L-cysteine is an excitotoxin. Glycine magnifies excitotoxicity. And these amino acids are released and highly concentrated in these different protein products. So if you get textured protein, vegetable protein, hydrolyzed plant protein, there are all kinds of disguised names. Whey protein, enzymes, spices, natural flavoring is a common name they use. Carrageenan is one of the newer ones. It's a highly inflammatory product. They use that experimentally. If you want to produce intense inflammation, you can inject that in an animal and they'll have an intense inflammatory reaction. Good thing to put in foods. Broth, stock. The names just go on and on and on. So you have to know the names to be able to recognize it. And you'll see foods that'll say, contains no MSG, but they'll contain 3 or 4 of these. And the law allows them to do it because the FDA law says that only if it's 99% pure MSG do they have to put it on the label. So it can be 98% MSG, and they don't even have to put it on the label. They can use one of these little names. And so you're not protected when you see it contains no MSG, or you go to the restaurant and you say, did your food contain MSG? And they say no. But it contains hydrolyzed vegetable protein or some of these others. And sometimes they don't even know. You'd be amazed how many people in restaurants have no idea that hydrolyzed vegetable protein is monosodium glutamate concentrate. Now, these are the foods that are especially high in excitotoxins. Anytime you use something like a gravy, if you use salad dressings that are commercially prepared, particularly diet salad dressings, they're all high in glutamates. And you'd be amazed when people say they go out and eat, and they have a salad, and they use the ranch dressing, and they have this horrible headache. Or they clouded in their thinking. They can't remember. That's because of the monosodium glutamate in the salad dressing. There are a lot of diseases and disorders that are associated with excitotoxicity, and this list is growing every day. They're finding more and more diseases that have anything to do with the brain is associated with excitotoxicity. It seems to be a central process in a lot of different diseases. And this is what we're finding out throughout medicine, is that there's just simple, central things that are causing a wide spectrum of disease. What makes the difference between one disease and another, whether it's cancer or Alzheimer's disease or arthritis, is the excitotoxicity is producing it in different tissues. We know that head injuries, if you injure your head, what happens is, we've known for some time that most of the damage that happens to your brain in the head injury doesn't happen at the time of the injury. That does happen, but usually not. It's delayed several hours. And we've gone through all kinds of contortion trying to figure out what is this delayed damage and how can we stop it. Well, now they've discovered it's excitotoxicity, because when your brain is injured, it releases glutamate from itself, because normally glutamate is a transmitter in the brain. It's the most common transmitter in the brain, but it's carefully regulated. When you injure your brain, it can't regulate it anymore, and it builds up a high level in your brain and produces the delayed injury that frequently results in severe neurological injury or death. Strokes. When you have a stroke and a block off a blood vessel is going to the brain, it is the lack of blood supply that causes the worst part of the stroke. That just kills a little tiny core of brain tissue. Around that tiny core, the brain starts secreting enormously large amounts of excitotoxin. And that's what causes the devastating aspect of a stroke. If we block those excitotoxins, the stroke is much, much less. And you can do that with something that God created called food. Hypoglycemic brain damage. When your blood sugar falls extremely low and people go into a coma or die, it's not because the brain cells are starved for glucose. It's because when they're starved for glucose, they release a lot of glutamate, and the glutamate kills the brain cell. AIDS dementia has recently been shown to be caused by excitotoxicity. Migraine headaches are caused by it. Anytime your nervous system is infected with a virus or bacteria, it causes the brain to secrete large amounts of glutamate, and that's what does the damage. Seizures are caused by glutamate excess, excitotoxicity. Most of your seizure drugs, anti-seizure drugs, block glutamate. All of these different things, degenerative brain disease, Parkinson's, ALS, Alzheimer's disease, the hottest area of research is the death of the brain cells by glutamate. It can cause immune suppression, episodic violence, and learning disorders. It carries out almost everything that you can think of in your brain is somehow connected to glutamate neurotransmitter. Now, this is the neurodegenerative process, and basically this is what is the central process for all those diseases I listed about excitotoxicity. That whole long list, this is what happens. And this is similar to what happens in cancer, surprisingly, and arthritis. We're finding that everything is a central mechanism. But in the brain, there's one little difference, and that has to do with this membrane here. It has a little pore in it, a little opening, a channel. This is microscopic. You can only see that on an electron microscope. And what this does is this little pore opens and closes. And glutamate controls the opening and closing of that little pore. Normally, there's very little glutamate outside of that brain cell. I mean, absolutely minute amounts, in millionths of a mole, okay? And it has to be that way, because if that level rises, it'll kill that brain cell. So your brain goes to a lot of trouble to make sure that glutamate level outside that nerve cell never gets above that 10 to 12 millionths of a mole. And it does that by a process where anytime glutamate's out there, it combines with a special transport protein, and that whisks it away and puts it in a cell called an astrocyte and stores it there until it's needed. Only when you're going to have a transmission of an impulse will it release it. And when it does, it breaks loose of the transport protein, attaches to its receptor, opens up the hole, and calcium pours into your cell. And then it whisked away again, and the hole closes. So it's only open for a millionth of a second, just enough to let a few molecules of calcium in. Once that calcium is in, it starts triggering these processes. And these processes normally, if it's just a little bit of calcium, what it does, it makes the nerve fire its impulse. If something happens and there's too much glutamate, it opens that hole up for too long, too much calcium gets in. If too much calcium gets in, then too intense of a reaction of these different processes take place, and it'll produce an inflammatory reaction in that cell with these inflammatory chemicals. It'll produce what we call free radicals, which are just very toxic chemicals that bounce around the cell, oxidizing all the components of the cell. One of the components it really damages is what we call the mitochondria. And that's the little part of your cell that produces almost all the energy that you use for everything, whether it's walking, moving, thinking. Mitochondria supplies the energy for everything. These free radicals generated by too much calcium damages that mitochondria. So it can no longer produce its energy the way it's supposed to. If it can't produce enough energy, the cell dies. It activates a gene called the p53 gene, which is the suicide gene in your cell. Cells are pretty smart. God made them that way. If this cell is damaged too bad by all these processes, and the cell knows that it cannot survive, it'll activate that gene and go ahead and kill itself. We call that apoptosis. And that's what too much calcium coming in will do. We also know that some of these products build up, they'll inhibit this transport protein so that more glutamate will start building up. So it's a kind of a cyclic process that just keeps going until the cell dies. Now, note with the knowledge that if too much glutamate out here is toxic, and it doesn't take a lot to make it toxic, does it make a lot of sense to add it to your food? Knowing that it transfers through the blood-brain barrier and will enter the brain, which we have proof of.
From that moment on, before you were a person, you're a diagnosis. You no longer have feelings, you have symptoms. Every mood becomes a symptom of your mood disorder. My lived experience became a liability. Much safer not to have one at all. And so years of my life were swallowed up in the void of dissociation. A kind of living death where the hollow shell of my body could make sure that it was nobody's problem. And when the cage of agoraphobia couldn't get any smaller, and the burden of my existence became too great to justify, I decided if I was on my way out anyway, I might as well try the thing that wasn't meant for me, that wasn't safe for a brain like mine. I decided to try psychedelics, mushrooms specifically. So I did, and for the first time that I could recall, I felt life inside my body, simply doing all the things that life does. And it was okay, and I was okay, and life was okay.
Hey brother,